Video is going to be a tutorial of how to reduce the length of a test using IRT modeling or item response theory modeling in R. Now, in a previous video, I went over how to run IRT models in R. I went over how to interpret some of the output produced, as well as the R code needed to run various types of IRT models like 1PL, 2PL, and 3PL. In this video, we're going to go over how to apply or leverage some of the information we get from IRT modeling to reduce test length, or basically, just reduce the length of a test. Now, there's sometimes you might want to reduce the length of a test because, let's say you might have a specific need where you might want examinees to run through the test a little bit more quickly, or you basically might want to reduce administration time. A lot of times, more items, the better, the more information you collect. However, there might be some times you might want to reduce it, and the goal here is to reduce it in a way where you don't compromise some of the psychometric properties of the test you want to maintain. Now, the data set that I'll be using is the same one I used before, which is the IQ data set. It's basically responses to this IQ test that attempt to, or they basically ask examinees to complete this pattern in this matrix. Similar, it's modeled after Raven Progressive Matrices. It's 25 items, and there are 400 observations. I've already loaded it, as you can see, into the global environment. Now, what I'm going to do is from that data set, I'm only going to select the items because there's some additional information in that data set. So let's call it IQ bin. Now, since the IRT model that we're running is the binary response, meaning that I want to dichotomize the data set into correct and incorrect. And for this specific data set, I'm going to I'm going to flag the correct ones as 1 and all the incorrect options as 0. Now let's load the package, the LTM package, which we'll use to run the IRT model. Now, next we will fit the 2PL model, the unidimensional IRT 2PL model. And to do that, it's just the LTM package, the name of the data set, tilde, Z1 indicating it's just going to be one factor. And that's pretty much all you need. And let's run it. And I basically named it IRT2PL. Now, the main goal is to take the 25 item IQ test and reduce it to a 9-item test. In this specific example, like, it may not be the best because it's already pretty brief. 25 items is pretty brief. So you might want to take this and apply it to something with a much larger data set. But this is just for demonstration of how to go over the R code and what to look for. So the first step we might want to do is, when we create this new shorter 9-item IQ test, we might want to just exclude misfitting items first. Then the next step is the items that we select from these non-misfitting items. We will want to only select items that provide the most information at given levels of theta. And I'll go over this a little bit more in depth as we move on. So first, let's run the function item.fit onto our IRT model, IRT2PL model. And let's name this fit. It just takes a quick second to run, and it estimates the chi-squared fit indices across all the items. in this one data set. So let's run it, see what it looks like. A p-value of less than 0.05 indicates that it indicates item misfit. So the next step, what I'm going to do here is I'm going to just put this data frame right here, well, this fit option right over here. I'm going to put it into a data frame using as.data.frame, but I'm only going to pull the p-values. This is what it looks like, and this is specifically what I mean. I don't know why I'm hesitating with that, but this is right here is just a column of p-values for each item because that's all I'm interested in right now. And then I'm going to take only the subset. I'm using the subset function of this column that I created, fit underscore PV, and I'm only going to take values, the p-values of greater than or equal to 0.05. So I'm excluding all the misfitting items. So now in this data frame right over here, or vector, it's only going to include the non-misfitting items. As you can see here, items 1 and 2 are no longer included. And I'll come back to this. The next step, what I'm going to do is I'm going to pull test information, and then I'm going to go back and merge it onto this. So in item information function is the reciprocal of the variance for the estimate of theta. It is related to how accurately theta can be estimated. The more information an item provides about a given level of theta, the more accurately that item can estimate theta at that level. So therefore, higher information at a given level of theta means more precision for estimating examinees who may truly possess that level of theta. So let's look at the item information function first. So let's plot it. And this plot looks terrible. Let's load it up a little bit higher. So as you can see here, well, actually we could just zoom in. All right, so here is each item and the amount of information provided by the item across levels of theta. By theta, when I use the word theta, I mean either ability, in this specific case it's ability in this IQ test, but depending on the instrument, it could be any construct that's being measured by the instrument, like anxiety or depression. So, what this shows is the amount of information across levels of theta, 0, 4, positive 4 indicating high, negative 4 indicating low levels of that theta or ability. In this case, it's IQ. And what you want to see is higher levels of information. But you have to understand that like each item may have more information at different ends, and that's okay. Now let's go back. That's what the plot looks, and that's the plot for each item individually. Now the test information function is the sum across the information sum across all those items together. And as you can see, it starts to appropriate more of a normal like curve for this test, meaning that information, for the most part, the information is not skewed to any one level of ability. And generally speaking, if that's the main goal of the instrument, that's what you want to see. So, yeah, and this is basically what I said, that the item in a test may likely differ in the amount of information they provide at different levels of data. Each item individually provides little information. Test information function is the sum of the information across all items. Now, the next step, what I want to do is I want to pull the information function for each item. So here's the plot that I originally used to get the item information function across all the items. Now I'm just going to list that information out, and then I'm going to put it as a data frame using as.data.frame, and I'm going to name it info. This is info now is going to be the name of the data frame that I'm using, where all the item information exists, and I will show you what that looks like. So this means it just maxed out, but the main thing I want to show is just what it looks like, because I have a lot of items. So what this shows is at each level of theta, indicated by Z in the first column, what is the amount of information possessed by each item. And I have like 25 items, and you can see theta goes from negative 3.8 and it'll go all the way to positive 3.8. Now what next thing I'm going to do is I just want to take the row value of the specific points in theta I'm most interested in. First, I want to take the row value 31, which in this case, it's basically negative 1.5. And I'll scroll to that right over here. As you can see here, the row value 31 is negative 1.5. That's what I'm doing here. From the dataset info, the row 31, give me columns 2 through 26, which is the 25 items, which begins at column number 2. And I use as.dataframe, as.data.frame to put it into a data frame, and then I'm just going to take T. T indicates I'll transpose that, meaning I'll take this row value and just transpose it into a column, just so I can merge it later on. And I'll call this column or vector or dataset low ability. And I'm going to then do it for medium ability as well, which in this case is going to be row 51, which is going to, if you look at all the information, row 51 is the closest value to theta is equal to 0. And then I'll do it again for theta is equal to 1.5, and you'll find row 70 to be that. So I'll take these 3 data sets. And again, each data set has the information value across the items. Now, what I'm going to do next is I'm going to merge each one of these data sets to fit_PV. This, again, is the data set containing the items that exclude all the non-misfitting items. So this is going to be the reduced data set. And all I'm doing here is I'm merging this reduced data set containing all the non-misfitting items, or excluding misfitting items, and I'm merging it with all the information functions for each one of the items. And I'm doing this for each data set. I'm doing this for the low information data set, the medium information, high information data set. So let's run that. And just to show what it looks like with this merge, and basically the merge function is the 2 data sets I want to merge, and I have to by is equal to 0 means that I am merging on the row name. In this case, the row names are the names of the items. and all dot x is equal to true, it means it's a left outer merge in that everything low ability has 25 items here, but this only has the reduced set of items, so only the items that match to this reduced set are going to be included in this new data set. So let's take a quick look at what this data set is. So what it shows is the row name, which is the name of the item. In this case, this is Q10 or item number 10. The p-value, which indicates it's non-significant, meaning it's it fits well. And the item information function. Now the next thing I'm going to do is I want to sort each one of these data sets using the order function, and negative meaning descending on the item info. The name, this is the name of the column where originally the row name. And I just want to take in brackets here 1 to 5, meaning the first five of these rows. So what does this look like? So I'm taking here in this data set right here is I'm looking at the items with the highest amount of information at the low end, 31 meaning negative 1.5, the low end of theta. Here, I'm taking the top 5 items that provide the most information for theta is equal to 0, and here I am taking the top 5 items with the most information for theta is equal to 1.5. Now basically I have all the information I want here, and this is what I'm going to use to pick from to create the new 9-item data set. I'm just going to take the top 3 of each of these. Now there's some over, and then this is more of it would be up to the person how you want to put together this data set. This new instrument. But the one quick way to do it is, what I'm just going to do is I'm just going to take the top 3 of each, and if there's overlap, like for example, I'll take item number 16 from the low end, I'll take item number 15 here. But as you can see, these items also, like let's say I just take the top 3 items here, 16, 15, and 3. So 15, 16 are already here. So I might want to just move further down as well and just take 10, 19, and 24 instead here. And, if there's overlap, I might take 18, 24, since 24 already appears, I might take 12 instead. So I basically go down if I've already included that item. And the aim is just to create 9 items and have an even amount of items from each level of theta. What I ultimately end up with is items 16, 3, 11, 25, 15, 10. Well, and there's a few ways to do it. I don't think 16, 25. I think here I didn't take 24. One way is to just take one at a time, and then only move down if you need to. But as long as you take 3 items from each, and there's a few ways to do it, but this is what I ended up doing. And here, what I'm going to do now is I'm just going to, from the original data set, I'm only going to take the items that represent the 9-item test. So in this new data set, IQBin.9, it only includes the 9 items that I ultimately selected. And now I'm just going to fit the 2PL model on this new data set. And the goal is to look at the overall test information function and plot it for this new data set. And as you can see here, as before, it is somewhat normal. It's not skewed to any specific end, and you can say that a lot of the psychometric properties in specifically in regards to test information is maintained to a certain extent. Now, you will notice that much less information is provided. Let's go back and run the original test information function plot right here. And to run the test information function plot, it's plot the name of your model, type is equal to IIC, comma, items is equal to 0. So this is the item test information function for the original model. And let's just go back, and this is for the reduced model. And as you can see, for the original model with all 25 items, the test information goes up to 7. But for the short form, the 9-item test, or I should specifically say the 2PL model fit onto the 9-item test, the test information only goes up to about right under 5 here. So the one thing to note, it goes almost up to 7 for the full test, is that you will get more information the more items you have. So you are making some compromises by going with a shorter test. You will always be making some type of compromise, but you will have to decide whether these compromises are ultimately worth it or not. And in general, but just always expect to have this reduced test information provided. Now, in the end, you will want to fit this IRT model onto a new data set, meaning that you will want to pilot this test and collect a new sample of data, then fit the IRT model onto it. And yeah, so I hope you found this video helpful. Please let me know if you have any questions, or if there are any other topics you want me to try and tackle. Thank you.